Hey guys, welcome back to Math Savvy. I'm Stephanie, and today we are going to be talking about parametric equations and vector equations, which are two ways to describe a vector. This is a hot topic in multivariable calculus, aka Calc 3. And so we're going to talk about it. We're going to give some examples, I think 4 examples, and let's begin. Why not? So let's talk about what these two forms are. If you have one form, you can get the other one and vice versa. So what are these forms? The vector equation is as follows. P equals P0 plus VT, where V is the directional vector and that T is the parameter, which we'll talk about what that is. And then we have P0, which is any point on the line. And for this, you can kind of compare it to slope-intercept form of algebra that you learned all those years ago, y equals mx plus b. You have a direction and a point. So it's kind of the same idea here. So what are these points in the vector and the parameter? So in R cubed, we write the directional vector in the form x, y, z. And same with the point. It's going to be in the form x, y, z. However, the parameter is a one-dimensional scalar. So if you don't understand what a parameter is, think of time and a direction. So you start at a point and you move in the direction of the vector. When you multiply the directional vector by 1 second, 2 seconds, 3 seconds, etc., you're moving in a line. Anyways, let's distribute this out, and what do you get? You guessed it. You get the parametric equations. So these are the two forms that we're going to be talking about today. So I have 4 examples that we're going to go through, so you get extra practice. And let's go. Okay, example 1. Find the vector equations and the parametric equations of the line in R cubed through this point, -1, 2, 5, to 7, 2, -1. Okay, so let's find the directional vector. That should be easy here. So we're just going to subtract b minus a, and we get 8, 0, -6. And because we subtracted b minus a, we're going to start at the a as the initial point. So we already have that. We have -1, 2, 5 plus t times the directional vector that we just found. And that is the vector equation. It's as simple as that. So we distribute this out like we did earlier, and we get x equals -1 plus 8t, and so on. So y equals 2 for the second parametric equation, because when the vector equation, or when the directional vector is 0, then it's not moving at all. So y is always going to be 2 in this vector, or in this line. And yeah, so that's all you're looking for if you're asked to find a vector equation and a parametric equation. Okay, example 2. Find a line parallel to the y-axis and through the y-axis, and through the midpoint of the segment from 0, 1, 2 to 6, 1, 4. And as we did last time, let's just define these points as A and B. So let's find the midpoint. We know that that's going to be the initial point for the vector form. So let us take the midpoint. So half times A plus half times B, we get 3, 1, 3. Boom, we got half of the equation done. So find a line parallel to the y-axis. There we go again, y-axis. So if the line is parallel to the y-axis, think about it. So x and z directions will not vary at all. It will only move in the y direction. So boom, we get 0, 1, 0. And I have a little diagram drawn here for you guys. So boom, boom, clap. That's all you needed to do. Next example is going to be a little bit harder. They're just going to get harder. But we're already 2 down, so boom. Okay, example 3. Find a line perpendicular, that's the little symbol for perpendicular, and r cubed to the triangle with vertices A, B, and C that I wrote out here, and through point A. Great. So let me draw a little diagram. We know that the line is going to be through point A, and it's going to be perpendicular to the triangle. So shout out to Professor Dave. Yeah, Professor Dave on YouTube. I learned this from him when I was in Calc 3. Thank God for the math YouTubers, you know. Anyways, so we have this way. We call it the right thumb rule, or the thumb rule, something like that. This is what it's called up here. Anyways, so we have our pointing finger as A and the middle finger is B, and then whichever direction the thumb is going is the cross product of the 2 original vectors. So as you can guess, if you're trying to find a line perpendicular, you're going to be using cross product. So I wrote out the definition of what the cross product is here. So the reason why I bring up this right hand rule is because we have to figure out which vectors we're going to be crossing, right? So then I wrote out the thumb here. So we see that B minus A should be cross-producted, I just made that up, with C minus A, according to the thumb rule, whatever we call it here. So let's do that. So B minus A cross product with C minus A. Does that make sense? Great. So all we got to do is cross product that, and we'll get the directional vector. Okay, pause, clarification. What I am doing is subtracting the blue from the red to get 3 entries of the directional vector. Namely, I'm applying the formula that I wrote out in the green box for the cross product. We already have the point, so then let it be an exercise to write the vector equations and the parametric equations for you guys. I wrote the vector equation here. So yeah, for most of these problems, we're going to be finding a point and then doing the directional vector after we find the point. Does that make sense? Great. Okay, example 4. Find the line parallel to the xy plane, perpendicular to the line x equals 2t plus 1, y equals t minus 1, z equals minus t, and through the point 0, 1, 2. First step, done. The point we have found already. So we're going to find a line parallel to the xy plane and perpendicular to that line. So if a line is going to be parallel to the xy plane, the directional vector is going to be in the form something, something, 0, because it is not going to move the z in the z direction at all. So I just put A, B, 0 here. And we also have another restriction here, which is the perpendicularity to that line. So the directional vector of this line is 2, 1, minus 1, which we talked about earlier. That's what the parametric equation tells us. With the dot product, if you set the dot product of 2 vectors equal to 0, that shows that the 2 vectors are perpendicular. So I'm going to do that here. We have A, B, 0 dot product with 2, 1, minus 1. Set it equal to 0, so 2A plus B equals to 0. We're going to do some algebra here. 2A equals minus B. I'm just going to choose A to be equal to 1. We have to make sure that 2A equals minus B is true in order for the line to be perpendicular, okay? So then we get B, which is minus 2, and boom, that works as a directional vector because it is parallel to the xy plane because it's the z direction is 0, and it's perpendicular to the line, which we did it with the dot product being set equal to 0. Great. So pt equals 0, 1, 2. Boom. Plus t times 1 minus 2, 0. Okay, great. So that was the last example. That's about as hard as it gets, but they do all follow the same idea, which is finding the point, initial point, any point that it crosses through, and then finding the directional vector. And the directional vector, you're usually going to have it be parallel to something, perpendicular to something, or sometimes you have it perpendicular to a plane, etc. So thank you so much, scholars, for watching. I'm so happy you came and conquered these problems with me. Let us know if you need some tutoring on our website, math-savvy.com. And check us out on TikTok. We make some silly videos there. And happy math. Have the best day of your life, you guys.